experiment, we are finding the friction of the back tire on mud, grass, and gravel. And then how we did this experiment was I will drive my four-wheeler at a set speed, slam the rear brake, and lock up the rear tire, and then we will measure the distance it takes to travel and the time it took to stop.
For our calculations, we use the initial impulse momentum equation up here, and assuming that the only force stopping this four-wheeler is friction because the brakes are locked up, we substituted mu times normal force in here and mg for the normal force, getting this final equation. And since we knew our initial mass, velocity, and time, we have a range of different values for the percent of weight on the the rear axle, because we weren't sure how much actual weight was distributed once it started locking up and moving forward. And we are solving for the coefficient of friction.
Okay, so here we have 3 different scenarios on Excel, each one depicting the percentage of weight on the rear tires and the coefficient of friction for each one of the scenarios.
The results of our test were a little bit surprising. We thought that the grass would have the highest friction rating, but actually it was the lowest. We think that's because it was wet, it just rained the day before. But then after that, it went, as we predicted, to the mud being the second, and then the gravel being the most friction. And the friction on the tires, we're guessing, is about 0.53 coefficient. Wait, there.